education series. My name is Ken Lawrence. I'm the head sales here at Neuron, and I'm joined by Tom Fountain, who's our Chief Technology Officer. We're looking forward to a great discussion over the next 50 minutes. That's what we have planned. I wanted to go over a couple administrative points before we get in and have Tom start his presentation today. First, from an administrative point of view, any questions that you have, please type them into the question box on the webinar system. We'll integrate those and we'll go through those at the end. If there's something urgent, put an exclamation point next to it, please, and I'll try to interrupt Tom as he's going forward. So the webinar will be recorded and archived. It'll be available at Neuron's website, neuron.com. And we'll send an email to everybody who's on this session today when it is posted. You can certainly feel free to share that with your colleagues, and they'll be able to come in and see that on demand. So that, I guess, let's with that, let's kind of jump in and go through what our agenda is going to look like today. So basically, I'm going to just get us going here. We're introducing, as I said. Tom is going to talk about the application development backlog, some of the drivers of that, and why certain approaches today that are considered traditional IT techniques are insufficient to really address some of the challenges as we move forward. It'll be about a 15-minute or 20-minute conversation, and then we'll jump right into a real live demonstration of the Neuron solution, where we'll show you how our technology can be used to tackle a kind of representative of a type of problem that I think many of you would see every day, trying to source data and apply analytics within your own organizations. So let's just maybe define what the application development backlog is and put some context around this. I think it's fair, or we can all say that there's more data, more sources of data, and more variety of data coming out of the various systems and vendors that we all do business with every day. I think the other thing that's increasing is the pressures on the business to innovate, to respond, and to get answers to important questions so that the business users can get their very important work done. The one thing that is not increasing at the same pace, frankly, is time or money. Never seems to do that. There's less time to respond to these questions and certainly less money to respond to these questions. And so that creates what Gartner references as the application backlog. These systems become more and more difficult to build. They take longer to get done. They take more money to get done. And so therefore the backlog of business systems just continues to increase. The other dynamic of that, and Forrester represents about 80% of money spent for many of these projects, is around data integration. And in fact, over half of that money is spent reintegrating data that's been used in other BI projects. So you've got this vicious loop of more and more systems coming online, more and more solutions being needed, and people redoing over and again the data. And so what we're going to talk about today is an alternative approach to that. How do we allow you to deploy business applications faster? How to take out some of the key challenges that are holding people back from fast development cycles today, and get tools in the hands of users more quickly. So with that, I'm going to turn it over to Tom Fountain, our Chief Technology Officer.
Great. Thanks, Ken. Welcome, everyone, and we certainly appreciate your time at a busy time of the year. As Ken said, we'll spend a few minutes talking about some context of the problem, and then we'll actually go into the live demonstration. And let's move right on. So it's useful to set a context around just what is driving this backlog. Many of us who have been in the IT function for a long time in development organizations have been dealing with a set of traditional drivers for a long period of time. Tight spending, shorter product cycles, globalization and the fight for talent. These are things that have been stressing organizations for a long period of time. Over the last couple of years, there's been an emergence of a number of important technologies that have opened up tremendous opportunities in the business. I've listed a few here which have garnered much of the press over the last couple of years. social, mobile analytics are greatly expanding the horizons of what a business can do to understand its customers, understand its operations, understand its whole marketplace. That, along with cloud driving a desire to re-platform and take advantage of economies of scale, is introducing tremendous opportunity, yet a great deal of complexity because of the variety and volume of data, the distribution of different assets that you want to incorporate into your operation, and even fundamentally moving parts of your operation out to a cloud-type environment. This quote at the bottom, I think, is illustrative of the challenge. In the old days, maybe a few years ago, we simply had to do things faster. Now we've got to do new things, not only faster but better. It's a relentless challenge for organizations to deal with this change and have the kind of agility and focus that's necessary to succeed, and at the same time keep an eye on the traditional challenges of security and efficiency and the like. So if we move forward, where's the backlog really building the fastest? And this is a really simple graphic, but it's very important in that much of the spend today is really centered in or distributed across two endpoints. The maintenance activities and even still migration to the ERP world is doing great things on the transaction processing side. Of late, major portions of the spend have gone into big data and now advanced analytics on top of that data. It's producing tremendous insight, but yet most of the demand that we're seeing is actually crossing multiple functions, different lines of business, and it's represented by this set, a diverse set, frankly, of internal customers who are asking for solutions that you could characterize them as faster time to value, more agility, lower total cost of ownership, to help them solve operational issues, to help them solve compliance issues, things that neither big data alone nor transaction processing systems alone can actually solve. And it fundamentally requires you to pull information, interact with applications, and have that all work together seamlessly to solve the specific business problems that get represented. With so much of the spend being on the endpoints, in many cases the backlog is growing dramatically in these types of solution areas. As we move on, and I apologize for a bit of a busy page, but it's an important page. What I've done is I've profiled different application strategies that have evolved over, frankly, a couple of decades. And you see a real split between application-centric approaches, things like SOA, traditional commercial off-the-shelf, and even of late SaaS-based applications. And they tend to deal very well with a wide variety of sources, interacting with applications and the like, to solve a specific application need. If you go down the curve, down to the lower right, we've seen over the years the ETL, data warehousing, reporting, and now the big data and advanced analytics elements do a fantastic job at the very robust analytic requirements, generating new insight from these large volumes of data. The challenge, however, is that this new type of demand is well off of that traditional trade-off curve. We'll characterize it as analytical applications, which is a bit of a mix of the two, but is very representative of the types of questions and challenges that are being asked on the prior page. And they very much exist in between those two endpoints, as we discussed a moment ago. And what I've characterized here in the upper right is this composite score, if you will. These requirements for short time to value, low TCO, high agility, frankly don't fit the traditional paradigms particularly well. And I've color-coded those a bit, and we could have some conversation around the reds and yellows and such. But this new category really requires a rethinking of the strategy that you can apply of how to deal with, at the same time, a diverse set of sources, but also to embed or involve a core element of analytics to help you rapidly solve these problems. You just simply can't afford to deal with the very heavy prerequisites of either complex systems integration or the massive data centralization, normalization, optimization challenges that you would see in the bigger data or even in the data warehouse arena. So that characteristic is a very hard one to solve for in the past, given these traditional approaches. And it's crucial to make sure that when you think about your demand, that you profile that demand and apply the appropriate solution strategy that was going to be successful for your business. Now, I'm going to shift a bit into Neuron and talk a bit at a high level about our headset and how we approach this opportunity. In a traditional way, applications, data, and process are all critical elements of this type of demand. On the application side, it's about unlocking valuable IP. On the data side, it's how to take fragmented sources and generate intelligence so that you can use it productively to be more informed for your decision making. And on the process side, it's all about how to realize actual business value by executing robust processes that mix and match these set of capabilities. The challenge has been that each of these areas are particularly challenged when you look at that variety of traditional application strategies. And the Neuron proposition comes into play, and we'll take these sequentially. On the application side, if you're going to meet the fast time to value, low TCO, you simply must avoid, wherever possible, the very time-consuming and costly replacements and rewrites. The Neuron headset is to expose the key functionality through what we'll call rapidly configured and interoperable objects. We'll discuss those in a moment. On the data side, it simply is prohibitive to try to pre-aggregate these very, very large and rapidly growing volumes and to do all of that work before you can start creating value. Our approach is to extract only the targeted information and data that you need to solve the specific problem, and further to do that as proximate to the source as possible. And we'll discuss the distributed aspects of Neuron in a few moments. But when you can target specifically what you need for the business problem and avoid that costly prerequisite, you have a major opportunity to cut time and cost out of the equation. And finally, on the process side, rather than having a very tight connectivity with systems rationalization opportunities and needs and so forth before you can get value, think of Neuron as a virtual, non-invasive fabric that overlays your diverse set of assets. That could be databases, that could be files, it could be websites, it could be web services, and so forth. And our approach is to allow you to tap into this diverse set of sources, to bring those specific points of value together, and to orchestrate activity that will create value in a very focused and efficient manner. The founding mission of the company was to enable a 50% improvement in time to value and TCO, but importantly to maintain a very high degree of agility. Many of the problems that we work with customers on require constant change. Changes in business requirements, changes in regulation, changes in customer or competitor behavior, all require a high degree of agility and flexibility to deal with those changes without disrupting the economics of the time and TCO objectives that we have. So let's talk a little bit specifically about the Neuron Platform. And as I said, think of it as a distributed processing and control fabric. We are fundamentally a development, deployment, and execution platform. And we overlay these diverse set of sources, but we are not invasive to those sources. We don't require agents to be installed on those source systems. Instead, we will leverage the connectivity options that typically exist within your enterprise already. Things like JDBC connections or HTTP or web services to allow you to make the connection and extract the value that's required for the particular business solution directly from those source systems. And very importantly, that is specifically done at runtime. Now, as we go down a layer, we get to the Neurons layer. Neurons, think of those as configurable mini applications. We have a broad library of neurons, and the essential paradigm here is to take your business problem and decompose it down into constituent pieces. You then select, configure, and connect the appropriate neuron to meet that unique need and string those together in the form of a network. That network can itself be distributed across our runtime server, or Cortex, to as broad a degree as you'd like. You have to have at least one Cortex to host the neuron, but typically multiple cortices are installed to give the solution architect and the designer the flexibility of deciding where to locate the processing, where to take advantage of proximity to different sources, perhaps take advantage of some higher compute capabilities, but fundamentally to allow you, the designer, to distribute the workload in an optimal fashion. This wide range of neurons can be organized in a serial fashion or a parallel fashion. And importantly, the cortex is managing all of the elements of the distributed fabric that we've been talking about. So in addition to providing the processing context for a neuron, the cortex also handles all of the messaging, all of the integration work, the resiliency, and the scaling that's required to execute successfully in this distributed environment. We can get into much more detail on the cortex if there's interest and questions, and certainly after the fact, we'd be happy to go into more detail. But the cortex is fundamentally providing the foundation to execute the business problem. And importantly, a wide variety of technologies have been pre-integrated into the cortex so the designer can stay focused at the logical level. We'll do this in the demonstration. You'll see that the selection and configuration of an individual neuron is very much a design activity, not a coding activity. And it does not require knowledge of the specifics of how these connections are being established. Instead, we emphasize the developer productivity of being able to select, configure, and deploy these neurons in a very efficient manner. So with that, let's transition to the demonstration. And I'll go ahead and I'll set this up fairly briefly, but it's a useful example to talk through. It's the end of the holiday season for shoppers, and the scenario that we'll offer is a retailer who's got a sales problem, frankly. And what we're going to show is a very simple application which allows you to interact with two distinct sources. Given that those two sources in this case don't have a direct linkage, we need to do some matching to ensure that the records in each of the two systems are properly brought together. We'll then apply a model to help us understand the propensity of the individual customer to potentially want to buy something, and then we'll alert the salespeople to proactively call that highly scored opportunity. The sales manager, you can imagine, is very urgent about this, so it needs to be built and delivered in a very rapid fashion. And I'll just suggest that you keep an eye out for some of the following items to help us connect what's in the demonstration to what we've been speaking about. Dealing with a diversity of sources in an efficient manner, doing the non-invasive aspects of the integration, all help in the time to value elements. From a cost of ownership point of view, the interoperability of these individual neurons and the breadth of functionality that's been pre-integrated help you sidestep a good deal of the prerequisite costs that you would typically incur. And the ability to simply configure and add or change the flow of different neurons help infer some of the agility that we think is so critical to responding to the business needs. So with that, I'm going to switch over. And what I've brought up is our design studio. And in our design studio, you'll see similarities to a business process management environment where you are orchestrating activities that will accomplish a specific business task. What I'll do is I'll give you a high-level view, and I'll actually run this network so we can see the result, and then we'll walk through a few of these specific elements, and I'll also bring in a few of these other neurons that I've pre-positioned but are currently not a part of this working network. So in these first two steps, we're gathering data from these disparate systems. So I've got queries going on, and we'll go into these in just a moment in terms of some detail. But I'm getting some customer data first, and then I'm going to also gather some rewards data that comes from a separate system. I'm going to then do some matching to ensure that the customers in the two properly match before I start to blend their data together. I'm going to check that match quality to ensure that that match reaches my threshold. I'm going to also, just for illustrative purposes, I'm going to show on our console those records that don't meet that match threshold. But the ones that do will follow the true path, if you will, and will calculate the actual propensity to buy. I have a very simple mathematical equation in that, but we'll get something more sophisticated in just a moment. We're then going to route based on the score with our case neuron, and I've laid out three separate paths. So by simply vectoring that unit of work accordingly, I'm going to send an email for a high-value opportunity. I'm going to persist the result for future use into a database, and I've assigned a default path if it doesn't hit either of those other two conditions. And it's a good illustration of being able to interact with your messaging environment where you could send that unit of work perhaps to another application to be further processed and perhaps make another decision. So when I open up this first neuron by right-clicking, you're going to see that we have a fire option. Neurons can be accessed via web services so that a third-party application could interact with them. You could also fire on an ad hoc basis, as I'll do here, but I'll also point to this scheduled neuron, which I'll show in a moment in terms of detail, but you can set up a scheduled neuron that will automatically fire off a network. So by simply clicking on the fire button, I've launched that network, and it has now launched and is going off. And we'll check my inbox in a moment, and you'll see that I've gotten a high-value alert that will tell me, that was just the pop that just happened. I'm going to give a quick refresh. And that email has just popped in, and I've actually routed the relevant information from the customer records where I've combined information about the customer, their phone and email, and some history about their transactions and their rewards points, and a propensity score. And because the propensity score was high enough, it was classified as a high-value alert, which I put in the subject line, and I've routed it right to the salesperson to spur them to call and immediately get after that opportunity. You can easily think of other applications of this type of approach. By instrumenting the different operational processes in your environments, you could set up alerts to operators who have to deal with infrastructure. You could send it to auditors who need to know that two balances don't match. The list could go on and on. But importantly, the configurability and the flexibility allow you to apply this type of a paradigm to many different application areas. So with that, let's take just a little look under the covers at a few of these different neurons to give you a flavor of how they vary and how the configurations work. In this query neuron, I'm going to open up the properties editor. And what's important about each neuron is that they have their own distinct set of properties. A query neuron naturally needs to access a data source. And if I do the drop-down, you'll see that I, as a specific designer, have been permissioned to access a fairly wide range of databases. These are actually what we call aliases, which are credentialed connections that have been established by myself, if I have the credentials, or by perhaps a DBA. And that DBA will give me specific access to a particular instance, perhaps of a database, and I can simply pick that from the particular drop-down list for the business problem I'm trying to solve. The other important property is the query. And I'm going to open up our visual query building tool. And what's happening is that as I'm opening up that query builder, it's running off to the database, it's reading the schema, and it's bringing back for me the set of tables and within that the fields that I have access to. I have already configured this query neuron, so you can see I've used the customers table, and I simply click through the fields that I wanted to use. I've retrieved most of them here. But importantly, as you make changes like adding aliases or where clauses, it'll dynamically generate the SQL statement for you. Now I've done this. We're going to do it live in a moment. But that's a good representation of getting specific targeted data to solve the problem you have at hand. Now, importantly, the way to think about this is that when a neuron is fired, it will execute that specific configured set of instructions, and it will produce a result set. And what I'm going to do is I'm going to show you the generated tags. And what we call tags are the names of the fields that are produced or passed through by a specific neuron. Whenever I draw a line between two neurons, I'm actually creating a message that at runtime will be packaged as a self-describing XML message and sent to the one or more subsequent neurons. So this second query will have available to it this set of fields as inputs to be used or frankly ignored to help it execute what it's been configured to do. So a good example would be I could use the customer ID field from the first query in the where clause of the query on the second database to provide that join effectively across two diverse databases. Let's open up the matching neuron. And as I open up that matching neuron, you're going to see that there's really just one key property, which is the editor that specifies the activities from an analysis point of view that are going to be applied. Within that, I have a very comprehensive capability to declare and set variables. I can create if loops and while loops. I can do a variety of either complex or fairly simple processing. In this particular case, I've declared a match score. And within the set statement, I'm going to assign the activities in terms of the formulas that I want applied. And in effect, what I've created is a 4-point match. I'm going to match based on last name, first name, street, and zip. And you can see it's probably a little hard to see, but I've got the customer information from the customer database, and I've got the rewards information from the rewards database. Now, importantly, we have pre-embedded a significant number of algorithms already into the matching neuron. And as I open up the matching library, you'll see 50 to 60 different high-end matching algorithms that allow you to select what's appropriate for the type of data you're matching. Now here I've chosen perfect match without case, but I could use these very sophisticated matching algorithms like Gero or Gero-Winkler, which are all variations of different probabilistic matching routines. It very much is based on the flexibility of choosing what makes the most sense for your given project. And I could simply just replace perfect case, and I could put Gero in or whatever is appropriate, save that, and I've made the change in my algorithm choice for the problem at hand. The agility is very obvious, in terms of making those changes quickly. Checking match quality is a simple neuron that I'll open up quickly. It's a very simple statement that says if the match score is greater than 75. Now we have a more sophisticated case neuron which gives you multi-branch routing, but this is useful in cases where it's a very binary decision that needs to be specified. And what that creates is 2 output paths. I can send on the true path where the matches exceed that value, and in the other case, I'm going to follow the didn't match or false path. And if I open up our console, you can see there's a set of records, and this is our simple console, but you can see the match score is 0, which makes sense. It didn't hit the threshold of 75, and that is giving me some visibility. And this print neuron is a very useful tool, typically for debugging and so forth. In addition, we have a full debugger I'll just mention, but I won't show. Our analytics neuron, I'll also show very briefly, allows you to do some very sophisticated math. It looks very much like the matching neuron in terms of having a diagram editor. Here I've done some very simple declaration of a propensity score. Importantly, you'll see that I checkmark store variable and result. That makes sure that the result is passed out in that outbound message so that I can use it downstream in other neurons. If I left that unchecked, it's effectively a local variable that I could use just within the context of this specific neuron. In the set statement, I've done some very simple math to combine different elements of the data that's been retrieved from these 2 different systems. Again, very simplistic for this exercise, but we'll get to something more sophisticated in just a moment. Applying that math will give me a propensity score. And then finally, I'll open up just very quickly our case neuron, where you can create a multi-branch route based on conditions. You can name them conveniently, and that's what we'll display on the screen. And then you specify the specific project and target neuron that you want to vector that unit of work toward. Now, in this case, I'm sending each of these scenarios to neurons that are within this existing project. But importantly, within Neuron, you can actually build networks of networks, and you could actually route one of these paths to a completely separate project that you might have created and published for use by anyone in your organization simply by provisioning it. Throughout our platform, we have a low-level provisioning capability and permissioning that give the administrator very complete control over who has access to neuron types, networks, external resources, etc. So with that, I've now created these 3 route alternatives. We've already seen the output that's gone to email. This lower path, where the score was particularly low, I've actually persisted to a database. Now, importantly, in Neuron, we do not persist any data for you. You have complete control over where and when and how you decide to persist. Here, I've done it toward the end of my network, But if you have an interesting intermediate result, perhaps after match score, that you might want to keep historical reasons on, you could persist it at that point as well. It's completely under your control, and you have a wide range of output options. We support natively over a dozen different relational databases, and we continue to add as new ones come along. And then in this middle case, the medium alerts, what I've put here is our JMS publish neuron. That allows you to interact with a JMS queue that you might have within your environment, which gives you a path to pass this unit of work in the form of a JMS message, perhaps to some other application in your environment that needs to pick up this type of work and finish the processing of it. The emphasis on an end-to-end basis to give you the flexibility and the speed to create this overall network, and then have a variety of input and output options to fit into your environment. We are very standards aligned in terms of those interactions I showed on the earlier PowerPoint page, and we're very technology agnostic. Our entire platform is built in Java, and you have the flexibility of installing it in a wide variety of platforms accordingly. Typically, people will install, as I said earlier, multiple cortices, and we have some sophisticated capabilities around being able to cluster those cortices to create a higher availability scenario and to implement some dynamic scaling. So with that, let me also bring out another query neuron. I'll show you from the ground up what's involved in creating a specific neuron and its configuration. So I've created a new neuron called getPropensity. And the record set that I'm going to pursue is actually the database that I was storing prior low-value alerts in, because I could potentially want to use those in subsequent executions of this analysis. And so I'm going to simply connect these two neurons, and then I'm going to open up and configure this specific query. And this is similar to what was done a moment ago, but I'm just going to do it from the ground up. I'm going to pick the particular database where I have that table, and I'm going to open up the query builder, and I'm going to select this time the propensity table. And out of that propensity table, I'm going to bring a couple of fields. I'll bring the customer ID, I'll bring that past propensity score, and maybe I'll bring a couple of other data items. And you'll notice that you need to check the box in terms of being in the output as well, because you may actually want to use something like Social Security number on the lookup side, but you don't want it propagated down your network. So by simply checking those, and you can see that the SQL query is being dynamically generated as I was doing that, and I'll click Update, and I'm done. That query has now been stored and is ready to execute. As soon as an incoming message arrives, it will go and execute. And in fact, I missed one piece that I wanted to show, and that is back in the query builder. I had mentioned it previously where you can use the incoming fields as part of the where clause as an example. So if I scroll down just a bit, I'm going to match on the rewards ID, and I want to match it with the customer ID that came from the prior query. And the where clause will be added, and I can update, and that will now refine my query accordingly. Okay. Now, that's all well and good, and that's two, maybe now three different internal sources that I can interact with, but typically people also have external sources that they have either subscribed to or might be publicly available. For items like that, we have a couple different neurons, and I've put on the screen already our service neuron. The service neuron allows you to use web services to interact with whatever it may be in either internal to your environment or external. Now, previously, I created an alias that would give me the connection to the specific URL, and I imported the WSDL statement that would lay out and give me the range of functionality for this particular example that's available to me. So by simply selecting the appropriate method and configuring any inputs that might be required, you can now start to interact and retrieve a result set from an external source. Now, quickly, just to finish off this one other item, the propensity score that we calculated, that was a fairly simple bit of mathematics. But what if instead I wanted to reuse some existing logic in the form of a model that had been built by my analytics team? Well, I could wire that in, and by opening our predictive model neuron, what this gives you the opportunity to do is to import a PMML model that had been previously built in some other tool, or you might have even bought that model. And I'm going to find the right directory. I apologize. And what happens is it will import that model, and it will give you the, oh my goodness, Yep, now I got to find the right directory. Here we go. Benchmark. Oh my goodness, now I lost it. All right, I'll leave that aside for a minute. All right. That was the model I was looking for, and in about 5 seconds, it would convert that XML model into an executable. And that allows you to import prior logic that is available to now be run natively in this particular neuron and produce a prediction that you could then connect right to your route by score, and it would accordingly finish off the rest of that sequence. We also have other neurons where you can import rules ML compliant model so that you could apply a set of business rules to units of work that are coming through the network as well. Now, when you get done building a network like this, you can, as we said before, offer it as an internal service. You could fire it in ad hoc fashion and so forth. I'm just going to show a much more complete example to give you a quick view of some other tools that we've built. This particular is a much more sophisticated opportunity in terms of monitoring and managing the supply chain. So I'll just give you a very high-level overview. Here in a parallel fashion, we're retrieving data from multiple diverse sources. Some are internal, some are external. We've also put our start-finish wrap around that to ensure that this work finishes before we execute the next portion of the segment in this network. And then over in this follow-on segment, we're doing a series of predictive analytics. And then we're using a rules model to generate various alerts that, similar to the example we just showed, we can send those alerts out in a variety of formats, again, email, JMS publish, etc. That gives you quite a rich opportunity to work with, for example, organizations where you don't own their information or their systems, and it allows you a lot of flexibility to deal with parsing Excel spreadsheets as an example, using databases, using web service calls, HTTP calls, etc. And finally, the last item I'll just show very quickly is our dashboarding tool. We call it the Enterprise Control Manager. And you have the ability to build a custom dashboard by using these available widgets and configuring their specific behavior to display in any number of forms the different types of information that you've generated and want to use for different purposes. I'll also mention that you have the opportunity to expose variables on the back of a widget and even allow network controls that would allow you to control the execution or even rerun the entire network, which is a great way to give limited control to an end user to interact actually with the design. That's particularly useful when you're doing things like setting thresholds and you want to see the immediate impact in terms of output, refiltering perhaps, or rerunning of the entire network. So with that, I'd like to open it up for any questions, and thank you. Okay.
Here's the first question. I think this might have come in while you were building it, which is, can we use models that the in-house team has already built? I think that might have been the one you were having trouble finding.
Yeah, so if I had found it correctly, you would have seen a PMML compliant model in an XML form that you can use our predictive model neuron as an easy example and import that directly. What's nice about this paradigm is that you can actually replicate that neuron multiple times and dispatch units of work in parallel across multiple copies of that model to accelerate performance. But we support, as I said, rules ML, PMML, and we also can deal with SAS models as well.
Great. Okay. Here's another one. We have customer data that we don't want some of our employees to see. How does your system deal with that?
Right. So this is back to when I was showing the aliases in terms of making the connection to the database. we will work happily with views of databases and so forth. So the designer will only see the fields or tables within databases that they have specifically been permissioned to see. So typically a DBA will set up a view, or it could be a stored procedure, and we have a stored procedure neuron as well. So it can be very tightly controlled, and only that applicable data will be retrieved and brought into the network. And then further, we have a filter neuron where you may need certain elements of data in the early part of a network. You can then filter that out and drop it from that ongoing XML message so that only the elements you want to proceed down the network and perhaps get emailed or sent somewhere else would make it through that filter.
I think there's another question here about having divisions in Europe and data privacy. I think that's the same answer. So.
Let me just make a little spin on that one. So what's really key is when I showed the picture about the multiple cortices, what people have done is a couple of different things. They have taken one of those cortices and they've landed it in Paris or wherever their data center was in France. And they have taken the portion of the network that deals with the lowest level PII type of data, and they do all of the access and processing locally in that data center on that cortex alone, and only the more aggregated, obfuscated results get sent somewhere else in the network and therefore in other parts of the world. So the distribution of the processing and the control allow you to set up that type of environment where you can protect the privacy and be compliant with those jurisdictions.
Okay. Another question here. Are there limits to the number of neurons or data sources that you can put in?
Yeah, good question. Practically speaking, no. The only real fundamental limitations is just simply how much horsepower you can throw at large problems. But there's, fundamentally no limitation to having X number of cortices or Y number of neurons on a cortex, or how many different data sources you might want to interact with, on an environmental-wide basis. Okay.
Are there any other questions out there as follow-up?
Let's see. We've got one here.
One more coming in. Stand by.
What does the team typically look like that works with Neuron? Great question. Our tool is specifically targeted at really a combination of a business subject matter expert and typically an IT business analyst. What we've worked very hard to do is to make it much more focused on logical design rather than having to worry about the low-level coding and the systems-heavy side of it. So that combination of folks who naturally would be backed up by a systems administrator who's installed and configured the product and a DBA who might be setting up permissions, but the ability to incrementally select and configure and test neuron and strings of neurons make it much more accessible for folks who actually know the business problem as well. And we're seeing a lot of great collaboration being restored when those two folks can work together. And one other slant on that is we are specifically focused on providing a great platform and providing the training that allow an individual or a company to be largely independent of us within a very short period of time. We want you, the customer, to frankly have the choice of whether you do the work yourself or we train up one of your partners to do the work for you or you do it with them. And we do stay involved in some project work, but it's really not our prime focus to be, delivering large integration projects, if you will. There's a couple of other ones. I'll just keep going. I understand, we're at the 45-minute point, and we certainly appreciate everyone's time. If there's interest in follow-ups, by all means, just be in contact with us, and we'll certainly arrange a further conversation. So back to questions. Do we offer a workshop to see if Neuron would help resolve a problem and or a proof of concept? We do specifically do POC workshops, typically 3 to 4 hours. We'll send some materials in advance to make sure that we're both well prepared, but we will walk through with you the specific business problem, key requirements, key characteristics in terms of time to value and other constraints that might exist in your environment. And we will go through that dialogue, and then we will take those results of the discussion, and we'll go put together a response that would give you a very good indication of what a proof of concept could look like in terms of time, expertise required, etc. But it's a very standard, typical thing that we would do. I've got another one. What use cases are you currently solving for clients in what verticals? Another great question. We largely started in the financial services arena, partly because of the expertise among the founders of the company, but also because there's a very rich set of use cases around changing regulation, diverse sources, a lot of acquisitions, and so forth. We've worked heavily in things like anti-money laundering, where we have a very strong use case helping banks disposition the thousands of alerts that they get every day that come out of their transaction monitoring systems. That requires accessing typically 6 or 7 secondary systems, performing a variety of scoring algorithms that are modeled into a series of neurons, and producing a recommendation that the analyst can then work from and validate rather than having to do the heavy manual lifting that was previously required, and we're delivering 60 to 70% or more productivity to that operation. We've also been involved in insurance, where we've helped take 6 or 7 different P&L systems that were never fully systems rationalized into one. It was taking the customer days to bring together all the information for a total P&L statement. Now using Neuron in that non-invasive integration headset, that analysis can be run in an hour, taking information, providing that integration, if you will, but also understanding the linkage back to the source systems so that if information came in, it could be vectored to the right particular source system as well. We're also getting more involved in healthcare. Again, a lot of distributed systems, a lot of varying technologies, a lot of regulation change naturally, and there's also some great applications in manufacturing, pharma, and the like. Let's see, I'm going to see if there's something else. How would I interact with external business partners and receive data from their systems and use it in Neuron and then send them a result? So we run into this question many times, and in fact, that quick view that I gave of our supply chain transparency and supply chain management network, it is extremely common, even in healthcare, that the particular customer we're working with does not own or have control over their partners' systems. So what's key in that respect is to give as many options as possible to make the connection and get the value that we need or the information that we need from those source systems that are under someone else's roof. There's a couple of opportunities. One, you could have a neuron that reaches from your own environment over to and makes a connection with the target system in the customer's environment. Now, that requires access, obviously, but you can make that direct connection. As long as we can make the connection, we can interact and do the data query or the FTP pull or whatever it might be required. Naturally, there's other options where files are maybe pushed over and they're landed somewhere, maybe on a secure FTP server. Well, you saw our FTP neuron maybe when I flashed by it, but you could pull that file at that point, do the parsing and so forth, and then after the processing has been completed, you could potentially use one of those output options that I gave previously, or you could make a web service call off to some DMZ that's on the customer side that signals to them that we've successfully processed your information or whatever's required. So there's a wide variety of ways to interact in a mutual bidirectional way. So with that, I'd like to thank everyone. We greatly appreciate your time, and I'll turn it back to Ken.
Yeah, thank you, Tom. I appreciate that, and I'd like to thank everybody who submitted questions. That's great. That really helps with the interchange. As I said at the beginning, we're going to archive this and put it on our website, and we'll reach out to everybody when that's available for sharing. And any additional questions, you can certainly just reach out to us. All our contact information is at neuron.com. There's an information link, and we'll have certainly someone get back to you, whether it's a business question or a sales question. And finally, I'd like to thank everybody and wish everybody a great holiday season and successful end of the year. Thank you very much.